Hey, welcome back to the channel. Good to see you again. Thanks for joining. Today on the bench I have something a little different again. This is a Harman Kardon Tempo tuner. This is an FM tuner. Tube tuner, I believe. Uses the vacuum bulbs. I haven't done enough vacuum bulb stuff on my channel. I think I need to do some more. So this is actually kind of a little project. It's called Tempo, but it's actually model number is F10. So it's officially what it's called is an F10. And it's a little FM tuner, no AM. Pretty sparse on everything. It's got the copper finish, power switch tuning. And on the back, there's an input for the FM, interlock for the power, output, audio output, and then a multiplex output. So this suggests this does not have an internal multiplex decoder. You got to do that outside of the tuner itself. So this is just a basic picks up FM stations, and yeah, it tunes from 88 to 108. So let's give it a try. I acquired this one on eBay quite a while ago, and I just stuffed it in the pile and one of my to-do lists for the winter, and this is now time for this. So I have it hooked up to a realistic SA155. This is stereo integrated amp. I don't know where I got this from. It's just a piece of junk amplifier. And just before I started filming, I ripped out the RCA outputs for the speakers and installed a little speaker connector so I can actually connect real life speakers to them. It's a mono tuner, so I'm connecting up onto the right channel. And let's turn this on. And I have it set to tuner, volume's cranked, tuner's plugged in, so let's turn it on. I get a light, and I give it a very slight hum out of the speakers. Very slight hum. And let's give it some time to warm up. I haven't even opened it up yet. I know a lot of people say, oh, you gotta put dim bulb on it and open it up and check everything. I like just plugging things in and living life on the edge. So this thing here is drawing 7 watts from the power. So I don't think it's working at all. 7 watts, and I got a pilot lamp, and pretty much that's it. So we got some fixing to do. Tuning knob makes some banging, clunky noises, and it dial pointer doesn't turn or move, so we probably have a dial string job in the future. So let's have a look inside. All right, so this would explain why it doesn't work. Somebody robbed the vacuum bulbs out of it. Boy, what do we need? 6-volt vacuum bulbs. So yeah, it actually looks pretty nice condition. So here's what we need. We're going to need an ECC85, 6AU6, 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 ECC85, 6AL5. I'm going to have to see which tubes I have here. I don't know if I knew about this little situation already and ordered tubes, or if I just, it's been a long year and I don't remember much about this here. But I probably did open it up and have a look inside. Filter cap is still cold. So let's see what tubes I have. I'm pretty sure I might have ordered some. I don't know. Okay, hang on. All right, I honestly don't remember this receiver, this tuner, but obviously I did order some tubes, and these are Russian replacements. These are 6AU6s. I got 3 of these, so that's good. And I have Russian equivalent to the, what is this? Let's have a look at this. There is a tube in here, right? see what this is. It's pretty small, whatever it is. Okay, wow. So this is the equivalent to the AL6, 6AL5. Okay. All right. Actually, this one goes here. So let's try populating this. Is this going to work? Who knows? Okay. 6AU6. These are Russian tubes. I'm too cheap to get the originals, so I just go Russian tubes. Okay, this one here is a 6AU6. This goes in the IF strip. Nice brand new tubes. Looks like they have silver plating on the pins. Nice. So I was looking at this radio. It has a power transformer, and it has an isolated chassis. But there is two capacitors. If you can see these two disc capacitors between the chassis and the line and the neutral. But other than that, the power supply is isolated from the chassis, which is good. So let's get our last tube out. Okay, we have two of these, and these are my ECC 85s, I believe. ECC 85. So this goes here. Ooh, bent pins. Straighten these pins out. Okay. And one more. Yeah, this thing's been sitting so long in the queue that I can't remember ordering the parts. So I must have ordered the parts after I bought the radio, and it's been sitting for so long I've completely forgotten about it. Doing work for everybody else. I don't get my own stuff done. This one's a little bent up too. A little rough handling. Pins are very soft. Okay, last one. Alright, so let's get power to this and give it a test. Okay, before I turn it on, let's see what's going on with this. It's slipping on the dial cord. Dial cord's still here, it's intact. But it's not turning. And the flywheel is hitting the transformer. That's unusual. Maybe it got bent in transport. Maybe I just need to loosen those transformer screws and shift it west a little bit. It's getting stuck on this. And then what's going on with this? Why doesn't this turn? Looks like it's frozen. Spring's got tension. Let me get that transformer moved over. I'll try to anyway. Let's see here, loosen a couple screws. Maybe it just got banged in shipping. Perfect, look at that. It's like I bought one. We still have slipping. Lots of tension on the string. I don't understand why it's slipping. Unless somebody dumped oil on it. There we go. Alright. Okay, before I get too carried away, I want to check the electrolytic capacitor, the main filter cap, to see if it's shorted or what's going on. I don't expect it to be anything wrong with it because I just had it powered up and it didn't do anything. 7 watts, that's probably what the pilot lamp and the transformer was consuming. Oh, we got one more screw here. Let's have a look underneath. It's all printed circuit board. Cool. Okay. Really not much to see here. There's a few cracked solders. Better not poke around until I discharge those caps. Okay, let me flip this over. Let's see if we can have a look at this capacitor. This cap is 60-40-40 at 150 volts. They got colors there? Yeah, they do. Red, yellow, blue. Common's black. Okay, so let's take a little look here. If we got any voltage on this. Black. Where's black? Black's right here. The chassis ground. Yellow. Got nothing on that one. Red. Got 40 volts. Blue. 40 volts. And the other one is, oh, here's yellow. 37 volts. So I'm pretty confident that capacitor is good. Let's give it a try. Alright, my amplifier is on. And we got the volume cranked to maximum. It's connected. We have input signal. I got my Widowmaker here. So we got high voltage on this power switch and pretty much everywhere else, but keep your fingers out. Let's try this out here. Tubes are glowing. Quite a bit of hum. It's very quiet. That's full blast.
Oh, didn't see what the fuss was about.
Very, very. That's our local station. That's the only one that's coming in strong. But then of course I have no antenna hooked up. Let's try an antenna. It doesn't matter which one I connect it to.
Team Rodeo on the way. This is Luke Combs on Kissing Country 103.
That's better.
102 Now Radio.
Maxed out, delicious.
Sounds like it needs an alignment. Getting a lot of... Can you hear that distortion?
See you at the drive-thru for a limited time at the...
Il y a Sylvie Drapeau, l'actrice. Je veux dire, Sylvie a décidé à compter.
Hey, members, start.
It's working pretty darn good. I think it just needs an alignment for all those new tubes I put in. Just needs a tweaking. And I think it probably needs a new cap. But yeah, it's got quite a bit of hum. It's got a selenium rectifier here. You can see it here on the green. Let me unplug this. It's unplugged. Selenium rectifier. It's not getting warm. But I still want to check the microfarads on this, which is a matter of unsoldering each of these 3 lines and just connecting it to my meter. But yeah, it's working pretty good. Okay, so here's a look at the caps. I got them disconnected from the circuit. First one is red. The red wire, which 60 microfarad, had 150 volts. Here we go. It's down to 13.6. 100 ohm ESR. It's not too bad. Next one is the yellow wire, 40 microfarad, 150. And we're down to 2.1 and a 1.6K ESR. It's not very good. Last one's blue. It should be 40 microfarad at 150 volts. And we get 100 or 1.5 microfarad. Wow. 1.4K ESR. Well, no wonder we got a hum. So I'm gonna have to replace these. Okay, so I'm looking at this and seeing what else I can do to this or do for it. And I see there's a paper capacitor right here. 0.05 microfarad at 200 volts. It's a molded paper cap. I'll probably replace that. I don't think I need to order those. I should have some here. And the rest of them are all disc capacitors. These two here. Okay, you can see what value they are. I can't see this. I can't get in there to see. So yeah, I'll just replace this one. I've got these caps on order. Got all new tubes. And I've checked a few of these resistors. Probably about 50% of them are out of spec. I'm pretty anal about resistors being intolerance. I know it doesn't matter much on a tube radio or tube equipment. It's not that critical, but I still like to have everything in tolerance. When I see something out of tolerance, I get all excited. These are all 20% tolerance though. They have no bands. Some of them have silver bands, some have no bands, so 20%. They're probably good with intolerance still, so I don't know, I'll think about that. Really not anything else to do this thing. Just replace those electrolytics and resolder all these cracked joints. So I'll get busy on that. Made in USA, Astron Corp. Got some damage here. Astron, East Newark, New Jersey. This one here is bang on 50 nanofarads, so we'll put this one in. This one fits a lot better. Alright, the only other thing I want to do is resolder some of these sockets. Where should we start? Some of these are cracked, some of them look like they're ready to crack. So I'm just going to go through and reflow a lot of this. I have a feeling once I put those new filter caps in, it's going to work like a charm. I just did a quick thing with the ohm meter, and a lot of them showed pretty close to bang on, and a lot of them showed high. Alright, what's going on over on this side? This is cracked. Isn't this fun? Exciting watching solder a printed circuit board. Okay, what else do we have here? Let's do some of these. This one doesn't look like it flowed. There we go. Okay, this one's cracked. I think I pretty much got it here. I don't know. I don't see anything else just jumping out at me. There's one. Kind of looks like they were wave soldered. Alright, I think I got it all. I was thinking about this overnight and I'm at kind of a loss of what to do here. This instant here I have two capacitors. They're both ceramic discs. You can see the schematic here. They are listed as 10,000 picofarads each. There's two of them. And they go from both sides of the line to ground, or to the chassis. They're 1400 volt capacitors, 1.4 kilovolts. What I'm going to do here is I'm going to replace these two capacitors that go to chassis, from line to chassis. going to replace them with a couple of these X1 Y1 rated capacitors. There we go. That's what we're taking out. 0.01, 1400 volts. Now, put our new ones in. Okay. There we go. Okay, hold that there, hold this one here. Yeah, let's see if we can do this. There we go. tell it's been a while since I've done point-to-point wiring and hooking wiring. Okay, that's it, we're done. Let's have a look at this. Not the prettiest thing, but it works. Hitting that capacitor down there, these things are bigger it seems. Maybe they're not. They're smaller maybe. Yeah, they're a little bigger actually, the old ones. Alright, so my capacitors came in this morning actually, and I'm going to replace this with this. There's quite a bit of difference in size. Now I'm not going to restuff this. This is just a piece of crap paper capacitor, paper shell on an electrolytic. We got a wax filled end here. I'm not going to try and recreate that. I'm going to remove this. This is going to be gone. The wires are going to be gone. My plan is to just install these capacitors underneath. I have pretty much exactly 1 inch of clearance between the printed circuit board and the bottom of the chassis, so there's going to be lots of room for these capacitors. I can just tack one in wherever it needs to be, and then I'll have to secure them down, mount them to something so that they don't flop around. But that's my solution for that. This capacitor here is a zoom in so you can see it. On the power supply circuit, we got our selenium rectifier, and then we got our first 40 microfarad at 150 volts, and then we go through a 1K resistor, second capacitor here at 40 microfarad at 150 volts, and then it goes through a 330 ohm resistor, and then our final filter capacitor is 60 microfarad, and I'm replacing it with 100 just because it's easier to get 100 than it is 60. I probably could have got a 69 microfarad or something like that, but closer to the thing. But it's not gonna matter. It's actually gonna make it a little better, if anything. So I'll do that. I haven't measured what this voltage should be, but I'm assuming it's under 150 volts, considering they have 3 capacitors in series or in parallel that are connected across there. Let's have a little look at this cap here. It's actually surprisingly not that bad a shape considering its age. It did open up and go high in value, but yeah, you can see right here the seal in the end. It kind of bulged out and popped. It's kind of this wax seal. I don't know if it's wax or some kind of epoxy. And then this stain here, this is electrolyte that oozed out, and it's kind of spilled over the chassis where it soiled itself. But yeah, it's been replaced now. But 65 degrees Celsius, that's not a very good capacitor. You would think that they would try a little harder. Anyways, it's garbage now. Alright, so what I did is I replaced a 330 ohm resistor under here. That is the one that was in series with the power circuit, and it was showing 400, and I can't even remember now. It was way over 400 ohms. So I replaced it with a 330. That's a 2-watt resistor in there, and that should be plenty good. It should last. This 1K resistor I tested, and it tested fine. I also got to cut these leads off if I can get in here. Okay, so those resistors were good, and I put the new capacitors in. What I did is I just had a piece of self-adhesive foam block, and I put that down on the PCB board as like a little cushion or landing for it. And what I'm going to do is I'm just going to anchor these down with some silicone. black silicone here. I'm not going to use very much. Just a dab on each of one of these foam blocks. And then the capacitor can lay down on that and it can be anchored down that way. Don't need much, just enough to tack it. And that should do the business. Here's my filter capacitor. Lots of room, lots of clearance. You can see the bottom of the radio's probably got about 1/4 inch, 1/2 inch clearance. So that's going to be good. Those capacitors will stay cool. Another thing I need to do is I removed the paper. It was just disintegrating. See how it just crumbles? There was a black sheet of paper here, and what I did is I took a piece of cardstock, black cardstock, and I painted it, spray painted it flat black, but it didn't seem to come out as black as the original. Look at the difference. I don't know how they got that very black like that, but you would think black spray paint would come out black, but it's kind of a dark gray. So I'm gonna adhesive this down with some silicone as well. And I'm just gonna give it a light coating. And then I can slip it underneath the dial pointer. Actually, this dial pointer can get out of the way. I'm just going to put this in and let that set up. And that'll be my new background for the dial face. Put this rubber block back in. Slip this back down. Okay, so the radio's done. It just needs to be reassembled now. I'll let the adhesive set, and then we can power it up and give it one more test. But everything's done that I'm going to do. Yeah, I looked at these resistors. A lot of these are 20% tolerance, so they're really sloppy tolerance on these. So I'm not going to get too carried away. I replaced this capacitor here, and this capacitor here was a paper capacitor, and that was right on the, here I'll show you. That capacitor here was a DC blocking capacitor. It was a 0.05 at 200 volts paper capacitor, and it was just last shot out before it hits the output. So this is just to block the DC from leaving the tuner, and so I replaced it. Really not much else to say. You could look at this schematic a bit if you want. Pretty garden variety. Like I said, the power supply, halfway rectification, and then we got 1, 2, 3 stages of filter. It's an RC filter, and these are pretty typical of tube radios. They don't need a lot of current. What they want is a lot of low ripple. So what they use is they use a capacitor, and then they use a resistor, dropping resistor. But the current through this resistor is like maybe in the tens or maybe 20 milliamps, you know, tens of milliamps. So there's not really much drop across these resistors, but they do act as a cushion for the ripple. And then when you put it in between two capacitors, the ripple gets dissipated by these resistors, and gives a very nice clean DC output for the tubes. Output, we have two outputs. One's a multiplex output, which is straight shot out from the output of the tube, and the other is the audio output. Which they do is they run it through a 68K resistor, and they have a 1000 picofarad capacitor. And what this does is it just takes out the 19 kilohertz pilot tone on the stereo stations, because that'll come through on the output. So yeah, they just put that on there just to knock that 19 kilohertz down. Other than that, it's pretty straightforward. So you know, on transistor gear, sometimes they have a little chart where they have like Q1, Q2, Q3, and then they have emitter base collector, and then they'll have voltage readings on each of those pins for each transistor. Well, here they do things a little different. They have the tube, the pin number, and then they'll have the resistance. So you can measure the resistance, what it should be at each pin in the tube. One thing I noticed is this dial string is not, it seems to be slipping. And it's slipping when I crank it to the left. On the right it works fine. When I go right to the right, there's no problem. It seems to be gripping. And it's slipping right here where the cord wraps around the shaft. I thought maybe I had some grease on there, so what I did is I took a little bit of non-residue contact cleaner and sprayed it in here, and just to give it a little clean, just in case there was any oil, or the string might be saturated with something too. Another thing I did is this pulley here was not aligned before. It was down a lot more, and the string had an angle here. When it contacted the pulley, it had quite an angle to make to load onto the pulley. So what I did is I pushed it out. I pushed the pulley out this way, and now it aligns perfectly with the string, the direction it should be going. We don't have any friction there. Another thing I did is I lubricated all these little pulleys with a little drop of grease, and they seem to be going pretty good. On here we have, let's show you here, we have on the pointer, the back of the pointer, we have 3 dimples, 1, 2, and 3, and those slide on the sheet metal. So I put a little bit of grease on this on these 2 slide areas and worked it back and forth. Now it seems to be working good. And usually when you have dial strings that are slipping or are not working, it's because they've stretched out, they've lost tension. But this one here, the spring has got lots of tension on it, and the string has got a lot of tension actually. So that's good that way. If you find you lose tension on your spring, you can take the spring and cut it and shorten it and reattach it. You can take off, let's say take off 2 or 3 wraps of the spring, cut it off, and then bend the last wrap out to make a hook. Yeah, you can, and then what you're doing is effectively putting more tension on that spring. You're stretching it out farther. If you take off, maybe try it with 1 wrap first, and then cut 2, and see how it goes that way. You don't want to cut too much of the spring off because you'll put too much tension. Place the spring if you have springs around. Okay, so this is ready for dial glass. I glued the black face on. I glued on this little rubber block up here. This one's held in with the clamp. And then I got a rubber block on this side I have to put the dial glass in with. Okay, let's give this a little test here before we do some final assembly. Actually, we'll test it, and then we'll maybe see if it needs an alignment. The dial indicator is pretty weak. We got some hum coming up. We've got no output. What is going on here? Oh, it just took a while for those tubes to come up. Yeah, I think we're picking up the camera. Sounds a lot better than before.
Justin Bieber, who's actually up for 8 Grammys this year.
Getting a lot of hum.
Up for no Grammys, but just named the national hero for Barbados, which is probably like, 20.
I don't know why we're getting some hum.
Nous parlerons aussi d'articles dévoileurs dans la presse il y a quelques jours.
I believe this should be at 90.1 and the dial is showing 88.5. So I'm going to do a little bit of tweaking here on the alignment of the frequency. So that's what I'm feeding into the tuner. I got a signal generator locked in at 89 megahertz, minus 70 dBm signal, and it's modulated with a 1 kilohertz tone. And I'll show you what it says on the scale here. Hang on. So if you look at the scale, we're tuned in under 88 megahertz, so we're over 1 megahertz out on the tuning accuracy. Just kind of playing around here. So how do we get it back? This pointer should be halfway between the 88 and 90. How do we move that pointer back? Well, there's a number of ways. We could just move the pointer and be done with it, but that's not the right way to do it. Actually, let's have a look here. Yeah, this capacitor is fully closed, so moving this pointer is not going to help us because it's not going to go any more that way. Let's see what we can do here. If you look at the circuit, there's 3 coils. These are open wound air coils. There's one here, there's one here, and there is one under here. So which one of these do we adjust? Because one of these coils is responsible for the oscillator frequency. So let's have a look here. And the quickest ways to tell is take a plastic tool like this and just go in and give the coil a nudge. Just move the windings apart or move them together, and then you'll hear to turn up the volume here. It's very quiet. Go in here and give this one a nudge. Nothing's happening. When you get the right coil, let's do this one. There's a capacitor on that side. We have to go from this side. See, when I move this coil, it changes the tuning of the circuit. So this is our coil that we have to adjust. Now, what do? We want to adjust this way. So what we want to do is we want to speed up the local oscillator. We want it to oscillate faster so that it goes higher up on the band. I don't know if that makes sense, but what we do is we tune this here to where it should be at 89 megahertz, okay? And then to speed up the oscillator, we have to tighten up this coil. We have to squeeze the windings together so that it oscillates at a higher frequency. But if we spread the windings apart, it'll oscillate at a lower frequency. What we're doing is we're changing the inductance of the coil. So now that I got it set to 89 megahertz, what I go do is with my plastic tool is go in here and just nudge the coil windings together and to see.
Oui, c'est intéressant quand même.
Mais vraiment.
Moi, je vous cache pas que je me disais, mon Dieu, mais c'est incroyable.
If I can get it, find that signal generator.
Qu'il veut écouler. Certes, noir et blanc, il veut en mettre en vente chacune.
Il propose les 34 en couleur au prix de...
So now we nudged it, we're at 88 megahertz. We're getting there. We still have a long ways to go though. Since we have a station right in the way, what I'm going to do is I'm going to reset my signal generator to 88 megahertz, and I'm going to set this to 88 megahertz, and then we're going to try tuning it that way. Just going to slowly nudge it in. There it is. I think I went too far. Maybe I went too far. I don't know. Let me see, where is it? No, we're almost there. Keep going with the nudging. Squeeze the coil together. It's a really stiff wire. It's a heavy gauge. See where we at? Oh, we're almost there. Keep going. Oh, we're almost there. Let's see how close we are. Yeah. Try and get it as accurate as you can. We're shooting for 88 megahertz here, so I'll put the dial pointer right on 88. And you almost have to tune it past the point and let the coil relax back. It doesn't want to move. Coil's like a big spring. It wants to relax back to its original position. Still out. There, we got it. Okay, now let's test the high end of the band.
The new year from the administrative council at the town of...
Got a lot of garbage on it. Let's go 106. So what we were doing, we were adjusting this coil here. We were actually squeezing it together to make this oscillator oscillate at a higher frequency. So now at the top of the band, we need to adjust this capacitor here. This one here is the main tuning capacitor. This one here is your trimmer. So this here will trim up the top end of the band. So we have to find that capacitor. So we have three capacitors. We got one here, trimmer capacitors. We got three trimmer capacitors, one here, here, and here. And I suspect it's this one. So let's try adjusting it. First, let's try and find our beacon. It might be buried in the stations. Let me see. I'll rock the tuning on the signal generator. Okay, so we're at 106.9. When I'm tuned to 106 here, I'm actually receiving 106.9. So what we need to do is slow it down. So let's go back to 106. And let's open up this capacitor. By opening it up, I mean turning down the capacitance. So let's crank it out. find it. Where is our... Let me try hunting again. Yeah, it's moved closer. It's at 106.4 now. You can hear it, so let's adjust it here. Getting a lot of interference. Seems this has an automatic frequency. Okay, let's...
The season all day, every day. 105.9 Shine FM.
Yeah, it's right next to that station. Selectivity of this receiver is not the greatest. Let's try 105. Frequency 105 megahertz. We should be pretty close to it right here. It's the problem with my location is I can't really get a good open. The top end of the band is really crowded.
Rogers play.
There's the tone. It's right at 105. Let's set this to 104. Should be able to pick it up. It's there. It's just buried in others because there's a station at 104. Let's go back down to 88. And it moves slightly, not too bad. I can readjust that. Okay, so what I gotta do now is spread the coils apart. Perfect. And then I'll do the top end of the band. I'll keep going back and forth until I get it just bang on. I can't really do it on the top end because I get a lot of copyright music going on, and I can't really filter that out. I have to do it in between the stations or in coexistence with the stations. So I'll get a copyright strike if I keep playing around here too long. I don't want to do that. So I'm going to call that tuned after I finish. And it seems to be a good solid performer. So right in the owner's manual or owner's literature, they have some service data right here. If we look here, let's zoom in on this. So alignment procedure, we're going to start with the IF strip. So we're going to set our frequency generator to 10.7 megahertz. We're going to modulate it, and it says input signal point. FM mixer gang. I don't know what they're talking about. FM mixer gang. Probably what I'm going to just do, I'll just feed it in the antenna input and just crank up the volume on the 10.7, and it'll get, some of it will get through. And then we're going to scope the output at, it says right at test point. It doesn't tell you, well, there's only one test point on this radio. We're going to adjust the 3 IF cans for maximum gain and symmetry. Now I believe each can has a top and bottom adjustment, so we're going to go after each can individually, top and bottom. And then after that we do 10.7 megahertz with the same thing, and we're going to be doing the discriminator transformer, and we look for maximum gain and symmetry. We're going to be scoping that on the output. The adjustments for the FM band, I've already done these two adjustments. I did that at the beginning, and that's just to get your dial accuracy in place. So let's have a look at the schematic. Okay, so here's the test point, and it's sitting underneath this IF can between these this resistor and capacitor going to ground. So if you look at the, it's not marked on the board anywhere. You have to just kind of look for these two components, this 100K and this 47 picofarad, and figure out where there is a test point. Actually, they put a little rivet in the printed circuit board, and it's not marked in any way. There's no way to clip onto it, so you got to add a little wire to the test point so that you can clip something on. So first off, we'll clip it here, and then we'll do our IF of this one, and this one, and then we'll move our test point or our scope to the multiplex output, and then we'll do the symmetry on the discriminator, and we'll get this all set up. Alright, so I got it all wired in. I'm gonna let it's been warming up for about 5-10 minutes now. Let's see if we can have a go at this. I'll turn some signal on. You should see the scope. That is the signal coming off test point. Let's turn the RF on, 10.7 megahertz. And I got it at minus 10 dBm. It's a really strong signal going into the front. Let's turn it to 0 dBm. And actually, let's turn off the modulation for now. Let's see what we can do here without modulation. And let's just go in and start with this first IF can. So it wasn't too far off the peak there. Let's see if we can do this. It's hard to see. Right there, I think, is a peak. Let's try the bottom. Something's weird going on here. I haven't even turned anything and the signal's going jumping all over. I wonder if I got a cracked solder. This one doesn't want to turn. Great. Let's try a metal screwdriver. My connections are loose. Let me fix this. There we go. A nice strong signal now. Something's still twitchy with this. So maybe you got a bad tube socket. There are a couple of bad tube sockets here. Okay. Let's see if we can turn that bottom core. If I can feel it, I can latch onto it. Okay, let me turn down the volume on the signal generator. Either there's no adjustment on this bottom core, or there's no core there to adjust, because I can't feel anything. I can feel it. Oh, there it is. That's deep in there though. Holy smokes. That deep. Try a different screwdriver. There we go. Peak there. Oh, that one's tight. I don't want to break it. I'm going to leave it at that. Is it definitely hard to turn? Okay, I think I'm going to leave that one alone. Let's try the next one. Yeah, these don't want to cooperate. Okay, we got a peak here. See the bottom core. Okay, right there. Right there is good. Right there. Okay. Last can. Actually, it wasn't far out. I thought it would be a lot farther out with those new tubes in there. Let's get this peaked out. Turn down the volume on the generator. We're at minus 20 dBm right now, feeding into the antenna. Let's see here. Last IF can. This one's stuck. No. There we go. So I'm going to go through them one more time. First can. Oh, that's it there. That's it there. Right there. No, it's not going to get any better than that. Modulation. Getting any audio through. Should have a modulated tone coming through now. I'm getting a signal through. You know what, this last tube is giving me grief here. Look at this, it went out. I might have to do something with that socket. Here it comes. That last tube was out. Doesn't want to warm up. Here it comes. I wonder if that affected my last tuning on the last can. Let me check it. I don't think so. I think we're still good. Okay, now let's move on to discriminator. Tying right onto the output multiplex here. Turn this down. Turn this up. So we gotta find that sweet spot where there's the least distortion. Let me turn up the signal on this. There we go. I'll put a 25 kilohertz deviation. Get a good look at that signal. Okay. Okay, other way. Right there's a peak. The screwdriver doesn't reach. That one's peaked out as well. So I think we got it. You hear some distortion when you right there in the middle where there's no distortion. It's very fine tuning. Let's try different frequencies. It goes all the way up. I don't think we're going to get any better than that. I think we're done. Okay, so I'll shut this all down and we'll give it a band sweep and see how it sounds. Alright, let's do a quick sweep of the band here, see how it sounds. I know before it was pretty, had pretty good sensitivity, but the selectivity was kind of crappy. Like the stations were I don't know. We'll see how this goes this time. I don't have much signal.
Mon portefeuille d'actions a beaucoup augmenté chez les plus riches. Je vais vous donner.
It's nice and quiet now. It's not distorted like it was before.
She said, I don't believe it. Should I even bother?
And then it was swearing and having sex. Yeah, it was like it was a rapper.
Seems like we're getting all the stations and they're all in the right position.
Introducing my McDonald's.
And it's able to pick out stations right next to each other too. It's more selective, way more selective.
Alternative Edmonton. It's Resurrection Radio.
That's supposed to be 102.9 and we're actually at maybe 102, 2.3 or so. It's a little bit out, not bad.
Years now, we've been warning Edmontonians.
It's doing a lot better than when it did when I first turned it on, that's for sure.
To make sure
Well, there you have it. It's finished now. Replaced electrolytic capacitor, paper cap, and a 330 ohm resistor. It's a nice little unit. I wish I could use it somewhere. I set it up and use it. I would listen to this daily. This is right up my alley, this kind of stuff. But unfortunately, I don't have any place to set it up. But yeah, I'm not a big fan of the copper finish on the front, but still, it's a nice little unit. I like this. Anyways, that's it for this one. Thanks for watching, and we'll see you on the next one.